Hello and welcome to an overview of Kennedy Street Green Infrastructure Streetscape. My name is Seth Chard. I'm the Senior Advisor for Green Infrastructure with DC Water. I'm joined by my colleagues Kevin Perry, Principal with Urban Rain Design, and Nicole Holmes, Senior Project Manager with Nitsch Engineering. DC Water is the water and sewer authority for the District of Columbia. It also manages wastewater from the surrounding counties. The district has an antiquated combined sewer system that was installed over 150 years ago. The DC Clean Rivers Project is a 25-year project to reduce combined sewer overflows to the district's waterways using green infrastructure and deep tunnels. Back in 2013, DC Water launched the Green Infrastructure Challenge competition, a competition to drive innovative, replicable, cost-effective, and high-performing urban green infrastructure solutions for combined sewer overflow reduction. The team was ultimately awarded the project for 100% design, and the project was constructed and finished in 2018. As you can see in this existing conditions photo from 2013, the street lacks a sense of identity. It has wide sidewalks, both public and private, thin vegetation with an inconsistent tree canopy, and a streetscape that mobilizes vehicles over pedestrians. The high amount of imperviousness resulted in a lot of stormwater runoff contributing to the combined sewer. With that, I'll turn it over to Kevin Perry.
Thanks, Seth. So to create a better streetscape condition, the team followed a set of principles throughout the design process. First, we aimed to mimic natural hydrological conditions by maximizing the amount of pervious and landscape surfaces used to capture stormwater runoff at its source. We also looked at decentralizing and spreading new landscape areas throughout the project site to capture runoff in smaller doses. And key to this project's success was introducing a stormwater gradient that uses a top-down approach to manage stormwater runoff. And we can look at this more closely when studying the design concept. So here you see the overall site plan of Kennedy Street, and in general, stormwater runoff is conveyed from right to left on your screen. And again, instead of locating the bulk of the stormwater facility solely at the low point of the site, our design approach was to spread this landscape throughout the project area and capture water on both the vertical and horizontal planes. As such, we've added 35 new trees and preserved 5 mature street trees that vertically capture rainfall. When precipitation does reach the ground, we've created 520 linear feet of pervious paving along the parking zone of the street to absorb this rainfall before it creates significant runoff. Any runoff that is created is captured within 15 bioretention curb extensions and 580 feet of interconnected recessed landscape area that acts as a backstop to slow and infiltrate this water. And lastly, the project includes 4 dry wells that manage any runoff that could not initially be managed throughout the stormwater gradient. Because Kennedy Street did have so many unique conditions and a lot of stormwater runoff to manage, we needed to think outside the box and adopt a series of experimental design techniques that DC Water had yet to try. This included changing the street profile to what we're calling a W crown, using metal boardwalks within the sidewalk zone to layer stormwater space under pedestrian space, and introducing a concept called landscape infiltration gaps, or LIGs for short, to capture sheet flow within small landscape-filled strips. We layered in stormwater throughout this project using metal boardwalks. And this slide shows an area where an existing mature tree had grown and buckled the concrete sidewalk. But rather than removing the tree, we saved it and carefully designed a bioretention curb extension to be built and used metal boardwalks to suspend pedestrian movement over the new stormwater landscape. Not only did this approach provide space for runoff to be absorbed, but it also created an accessible path of travel where there once was none. The wide sidewalks along Kennedy Street provided the perfect canvas for us to try out the use of landscape infiltration gaps. At select locations along Kennedy Street, a series of parallel landscape strips captures and infiltrates sidewalk runoff before it reaches the parking zone. This again exemplifies our design principle of managing stormwater in smaller doses throughout the project area. Lastly, the street profile along Kennedy Street was changed from your typical crown cross-section into a W crown. This shifts the stormwater flow away from the curb line and places it further out into the street. This approach allows the pervious pavement parking zone to manage direct rainfall and does not need to also manage runoff from and the associated sediment from load from the street. We are hopeful that this approach reduces the maintenance burden for the project. And with that, I'm going to switch over to Nicole to talk about the construction process.
Thanks, Kevin. So the Green Infrastructure Streetscape project for Kennedy Street was a stormwater project, a stormwater demonstration project funded by the DC Water Clean Rivers Project. However, the project was actually coordinated with and constructed as part of a much larger streetscape renovation project for Kennedy Street. And as such, it required significant coordination with DDOT, the District Department of Transportation. Although we tried to use as many standard streetscape details and design elements as possible, the experimental aspects of this demonstration project required us to create some adaptations to typical design techniques that required close collaboration with DDOT and other city agencies. Slide. As you can see with some of the construction photographs, we used typical construction methods to install many of the features of Kennedy Street, including concrete forms to build the landscape infiltration gaps in the valley trench. We used a long continuous trench drain system to actually provide an interconnected culvert between the different stormwater planters in the sidewalk area. We used typical steel beams to install the graded boardwalks and overlooks and pedestrian ways, and permeable pavers in the parking lane, as Kevin described previously. And this is a post-construction photograph looking down Kennedy Street, similar to the pre-construction photograph that Seth shared previously. But you can see in the foreground the bioretention curb extensions. You're able to see the permeable paver parking lane and the valley gutter between the roadway and the parking lane, which again conveys water from the roadway only to the bioretention curb extension. And you can see some of the preservation of the large trees on Kennedy and the beginnings of some of the newly planted trees on Kennedy in this photograph. As part of our permitting process, we were required to illustrate at a minimum that this project block was able to retain the required 1.2-inch rainfall depth. And so using standard spreadsheets prepared and provided by the DOEE, the Department of Energy and Environment, we were able to easily demonstrate that this one block of Kennedy Street is able to store the equivalent of 1.2-inch rainfall through the various features. In fact, we ultimately provided 60,000 gallons of storage, which far exceeded the requirement for the block. That would be either the equivalent of 2.1 inches of rainfall over the project limit of work, or also the other way to look at it was that we were helping to enhance the performance of the adjacent areas that may run on and through the site. Part of what we had done during the design process was to develop hydrologic and hydraulic models to predict the interconnected nature of the features, and we always felt that the project would perform better than just looking at the raw retainage volume that we did using spreadsheet methodologies. DC Water actually engaged Greeley and Hansen to do pre and post construction monitoring for the street. And so this graph is representing the wet weather flow on Kennedy Street for various rainfall events. Gray dots represent pre-construction data that was gathered over at least a year. And at the time of this graph, we had about 6 months of post-construction data, and we're continuing to update this as more data becomes available. But even given the data we have available at this time, you can see the significant amount of retainage provided by the Kennedy Street demonstration project with significant reductions of wet weather flow, approximately 83% reduction in the volume of wet weather flow for both small storms and even larger storms that were captured. And this concludes the pre-recorded presentation. Thank you for your time. For more information about this project, you can visit the project website and feel free to contact any of the presenters today at the email addresses provided below. Thank you.